Welcome to the absolute edge of existence. We're plunging into the Mariana Trench, a realm where gravity is a weapon and survival is a masterclass in biological engineering. Let's descend. Imagine a world where every square inch of your body is pressed by 8 tons of invisible weight. It is the equivalent of having 3 heavy SUVs stacked on your thumbnail. In this absolute darkness at the very bottom of the world, the chemistry of life must change or be crushed into nothingness. This is the Mariana Trench, the crushing kingdom, a place so remote it feels more alien than the surface of Mars. Deep within the Hadal Zone, past the reach of every sunbeam, a ghostly figure glides through the freezing silence. This is the Mariana snailfish, a translucent marvel of evolution and the undisputed sovereign of the upper trench. It doesn't look like a warrior. It has no armor, no massive teeth, and a body so delicate it appears to be made of tissue paper. Yet it thrives where steel implodes. To survive here, the snailfish has abandoned the rules of the surface. It has no swim bladder, as any pocket of air would be a death sentence under such immense pressure. Its bones have traded calcium for flexible cartilage, and its proteins are shielded by specialized molecules that prevent them from collapsing. As it moves through the silt, it doesn't use eyes to see. It feels the world through a sensitive system of pores that detect the slightest shiver in the water. Every movement is a calculated play for energy in a kingdom that never forgives. This is not just a descent into water, it is a journey to the very limits of what it means to be alive. Could you survive a minute in a world of total darkness and crushing weight? Tell us your strategy in the comments. Subscribe to join our journey into the deep. Beneath the drifting silt and the silent glide of the snailfish, the very foundation of this kingdom reveals a violent history written in stone and gravity. This is the birthplace of the abyss, a site where the massive Pacific Plate, a slab of oceanic crust nearly 170 million years old, concludes its epic journey across the ocean floor. It is a collision of giants that has been unfolding for eons, yet it happens at the speed a human fingernail grows. To the west lies the smaller Mariana Plate, and where these two behemoths meet, the laws of physics demand a sacrifice. Because the Pacific Plate is older, colder, and significantly denser, it cannot remain on the surface. Instead, it begins a slow downward dive, plunging into the searing heat of the Earth's mantle. This process, known as subduction, is the architect of the Mariana Trench, tearing open a crescent-shaped scar that reaches deeper than the highest mountain peaks can ever dream of climbing. As the Pacific Plate bends and cracks under the weight of its own descent, the seafloor is literally ripped apart. This is not a clean break. It is a tectonic wound that stays open for millions of years. This ancient crust, dating back to the age of the dinosaurs, carries with it the chemical fingerprints of a world long gone. As it sinks, the immense pressure forces water and minerals out of the rock, triggering chemical reactions that would be impossible anywhere else. This is the geological breathing of the trench. Through the fractures in the crust vents and seeps, begin to leak methane and hydrogen sulfide, the toxic lifeblood of a kingdom that knows no sun. The rock here is not just solid matter, it is a sponge being squeezed by the weight of the entire ocean, releasing the energy required to fuel an alien world. The sheer scale of this geological event is difficult to comprehend within the brief window of a biological life. From the perspective of the creatures drifting above, these movements are felt as subtle rhythmic tremors that pulse through the sediment. These vibrations are the heartbeat of the abyss, echoing through the trenches like a distant low-frequency drum that never stops. Every few thousand years, a massive shift occurs, a subterranean landslide that reshapes the entire canyon wall, burying old ecosystems and exposing new mineral veins. This constant state of renewal is what keeps the trench from becoming a stagnant tomb. It is a dynamic living machine made of rock and pressure, constantly recycling the planet's surface into its molten interior to maintain the delicate balance of the deep. The depth itself, the staggering 11 kilometers of vertical space, is a direct result of how old this sinking crust truly is. Unlike younger, warmer crust found in other oceans, this Pacific slab is heavy with the weight of time. It sinks deeper and steeper, dragging the ocean floor down with it into the crushing darkness of the Hadal Zone. This is why the Mariana Trench remains unique. It is a window into the deep time of our planet, a place where rocks older than the Atlantic Ocean are being reclaimed by the Earth. It is a graveyard of geological history where the past is consumed to fuel the future of the organisms waiting below. Within these jagged fissures and steep cliffs, the environment dictates the behavior of everything that lives here. The steepness of the trench walls creates a natural funnel guiding the organic debris from the surface into concentrated pockets at the bottom. The geology doesn't just provide a stage, it provides the primary energy source. The methane seeping from the cracks serves as the foundation for massive microbial mats, turning a barren tectonic scar into an underground garden of chemical energy. Without this violent collision of plates, there would be no trench, no extreme pressure, and no secret oasis of life. The struggle between these two plates is the ultimate source of power for the crushing kingdom, proving that even in the darkest, most hostile corner of the globe, the Earth itself provides the means to endure. While the tectonic plates slowly consume the ocean's past, the immediate silence above the sediment belongs to a master of survival that has turned the crushing weight of the water into its greatest ally. This is the realm of the Mariana snailfish, a creature that appears more like a drifting spirit than a top predator of the deep. To a surface observer, its pale translucent skin and fragile tadpole-like frame might suggest weakness, but in the Hadal zone, this design is the pinnacle of biological engineering. Every aspect of its anatomy is a direct response to a world where bone would shatter and air would implode. By abandoning the rigid structures found in its shallow water relatives, the snailfish has unlocked the ability to reign over a territory 8,000 meters beneath the waves, a depth that marks the absolute frontier for vertebrate life on Earth. The most striking feature of this deep-sea sovereign is its lack of a swim bladder, the gas-filled organ that most fish use to maintain buoyancy. At these depths, a pocket of air would be a fatal flaw, a localized point of low pressure that the ocean would instantly crush with the force of a hydraulic press. Instead, the snailfish relies on a gelatinous layer of tissue that makes its body nearly incompressible. This jelly-like consistency allows it to maintain a neutral density, hovering effortlessly above the silt without expending precious energy. Its skeleton, too, is a marvel of adaptation. Rather than brittle calcified bone, it is composed of flexible cartilage. This supple framework can bend and compress under the immense weight of the water column without fracturing, allowing the fish to navigate the jagged fissures of the trench walls with surprising grace. Yet survival in the crushing kingdom requires more than just structural integrity. It requires a fundamental change in the chemistry of life itself. At the molecular level, the proteins that drive muscle contraction and nerve impulses are prone to collapsing under extreme pressure. To counter this, the snailfish's cells are saturated with a specialized molecule called trimethylamine N-oxide, or TMAO. This chemical acts as a stabilizer, acting like a structural brace that prevents the delicate proteins from being folded or distorted by the weight of the sea. The higher the pressure, the more TMAO the fish accumulates in its tissues. This chemical shield is what allows its heart to beat and its muscles to ripple in a place where the very building blocks of life should theoretically cease to function. In a world of eternal midnight, the snailfish has also evolved a sensory system that renders eyes almost obsolete. While it possesses small dark eyes capable of detecting faint bioluminescent flashes, its primary window into the abyss is its lateral line system. This is a network of sensitive pores running along its head and body, acting as a high-definition sonar that maps the surrounding water in 3 dimensions. Every flick of a scavenger's limb, every ripple caused by a shifting sediment grain, and every chemical trail left by a potential mate is felt as a distinct vibration. The snailfish doesn't just swim through the water, it listens to the pressure waves. It can detect the frantic movements of a distant amphipod or the slow rhythmic pulse of a nearby seep with pinpoint accuracy. This heightened sensitivity allows it to be a patient, lethal hunter, moving with a ghost-like efficiency that minimizes oxygen consumption while maximizing its chances of a successful strike in the dark. This mastery of the extreme allows the snailfish to occupy a niche that no other vertebrate can reach. It is the gatekeeper of the deepest trenches, a biological bridge between the productive waters far above and the chemical-fueled ecosystems of the seafloor. As it glides over the fine, ghostly silt of the plains, it remains a testament to the resilience of evolution. It has not merely survived the pressure, it has integrated it into its very being. But as the snailfish maneuvers through the shadows, a new vibration begins to echo through its sensory pores, a heavy rhythmic thud of a massive organic deposit descending from the surface world, signaling the start of a chaotic struggle for energy that will test even this master's limits. As the ghost of the abyss drifts further into the void, the jagged tectonic cliffs give way to a vast, unsettling horizontal expanse known as the Hadal Silt Plains. This is the Barren Silence, a lunar-like landscape where time seems to have frozen under the weight of 11 kilometers of water. Unlike the chaotic edges of the trench, where methane seeps provide a constant chemical pulse, these plains are a graveyard of the pelagic world. The floor here is covered in a thick fine layer of sediment, a ghostly dust composed of the crushed remains of plankton shells and volcanic ash that has drifted down from the surface for millions of years. Every centimeter of this silt represents thousands of years of accumulation, a silent record of Earth's biological history, resting in total, lightless isolation. In this desolate environment, the primary source of survival is the marine snow, a faint continuous rain of organic debris that survives the long descent from the sunlit layers above. However, by the time these tiny particles reach the Challenger Deep, they are stripped of most their nutritional value. To survive on these meager scraps, the organisms of the silt plains have evolved metabolic strategies that push the very boundaries of what it means to be alive. Here, life does not move with urgency. It exists in a state of near-suspended animation. The primary inhabitants are not hunters, but gatherers of shadows creatures that have mastered the art of doing almost nothing to stay alive. Among the most bizarre residents of this silent plain are the Xenophyophores, giant single-celled organisms that cluster on the sediment like alien flowers. These massive cells, some reaching the size of a human hand, construct intricate, fragile skeletons out of minerals they filter from the water. They are the structural foundations of the deep, providing the only shelter for tiny nematodes and polychaete worms in an otherwise featureless desert. They do not hunt or scavenge in the traditional sense. They simply wait, absorbing dissolved nutrients through their delicate membranes. They are living fossils of a metabolic era where speed was unnecessary and patience was the only true currency of survival. Beneath the Xenophyophores, the sediment itself is alive with an invisible empire of microbes. These bacteria and archaea are the ultimate survivors of the crushing kingdom. In these nutrient-poor dead zones, they process carbon at a glacial pace, some individuals living for centuries while barely dividing. They utilize rare chemical reactions within the mud, extracting energy from elements like iron or manganese when organic carbon is unavailable. This microbial layer forms a thin living film that coats every grain of silt, a microscopic web of life that remains active even when the larger world above has gone quiet. They are the silent engines of the trench, recycling the final dregs of energy before it is swallowed by the Earth's crust. As the Mariana snailfish glides over this powdery desert, it enters a zone of extreme sensory deprivation. There are no landmarks, no currents, and no sounds, only the rhythmic low-frequency thrum of the tectonic plates beneath the mud. To save energy, the snailfish slows its heart rate even further, drifting like a fallen leaf, its sensitive pores searching for any break in the monotony. The silence here is so profound that even the smallest vibration can be felt for miles. For hours or perhaps days, nothing moves. The plains remain a stagnant, frozen stage. But this stillness is deceptive. Far above, the massive organic deposit sensed earlier has finally breached the Hadal boundary. It is no longer just a vibration. It is a physical presence, a mountain of protein descending toward the silt. The barren silence is about to be shattered by a frantic, violent surge of energy that will draw every scavenger from the shadows, turning this desolate graveyard into a battlefield for the rarest resource in the abyss, food. The fragile piece of the silt plains is shattered as the massive organic deposit finally impacts the seabed, sending a shockwave of sediment and chemical signals through the crushing darkness. This foodfall, the carcass of a large creature from the upper ocean, is a windfall of unimaginable proportions in a kingdom defined by scarcity. It acts as a biological beacon, releasing a plume of concentrated protein and lipid molecules into the freezing water. In an environment where every calorie is a treasure, the news of death travels fast. Within minutes, the barren silence is replaced by a frantic rhythmic vibration as thousands of supergiant amphipods emerge from the shadows. These 7-inch-long crustaceans are the elite scavengers of the deep, and they have been waiting for this moment in a state of metabolic stasis. Guided by their hypersensitive chemical receptors, the amphipods descend upon the carcass like a living cloud of white ghosts. Their arrival is a masterclass in specialized adaptation. Unlike their smaller relatives in the sunlit world, these giants possess exoskeletons reinforced with aluminum, which they painstakingly extract from the surrounding sediment. This metallic fortification prevents their shells from dissolving under the immense pressure and the acidic conditions of the deep, allowing them to crowd together in a dense, writhing mass. They do not merely eat, they strip. Using powerful, serrated mouthparts, they tear through skin and muscle with surgical precision, vibrating their bodies to shear off chunks of flesh. The frenzy is so intense that the water around the carcass begins to churn with bioluminescent sparks, triggered by the agitation of microscopic organisms caught in the crossfire. As the amphipods occupy the center of the feast, the Mariana snailfish reappears moving with a calculated lethal grace. It does not join the chaotic pile of scavengers. Instead, it orbits the perimeter, its sensitive lateral pores mapping the frantic movements of the swarm. For the snailfish, the carcass is a dual opportunity. While it will occasionally consume the softening tissues of the fall, its primary targets are the distracted amphipods themselves. This is the apex move of the crushing kingdom. By waiting for the scavengers to gorge themselves on the protein-rich meat, the snailfish ensures that its own prey is packed with the highest possible nutritional value. It glides through the darkness, a translucent hunter amidst a sea of white shells, choosing its moment with chilling efficiency. When the strike comes, it is nearly invisible. The snailfish uses a sudden expansion of its buccal cavity to create a powerful vacuum, inhaling an unsuspecting amphipod before the crustacean can even react. The flexible cartilage of the snailfish's jaw and the lack of a rigid ribcage allow it to swallow prey that seems far too large for its delicate frame. There is no struggle, no wasted energy, only the cold mechanical reality of the Hadal food chain. This cycle of consumption from the falling remains of the surface world to the scavengers and finally to the vertebrate hunter is the engine that sustains life at the bottom of the world. It is a violent, beautiful orchestration of energy transfer where nothing is ever wasted. However, as the feeding frenzy reaches its peak, the snailfish's sensory pores detect a jarring anomaly. Amidst the soft textures of the decaying flesh and the hard metallic shells of the amphipods, there is something that does not vibrate correctly. A piece of the debris snagged within the carcass remains unnaturally still. It does not release a chemical trail of protein, and it does not yield to the serrated jaws of the scavengers. It is a smooth, indestructible shard of the world, above an intruder that has drifted 7 miles down to sit at the heart of the abyss. The snailfish circles this strange object, its primal instinct sensing a threat that evolution never prepared it to face, a silent plastic ghost that will change the fate of the trench forever. As the scavengers disperse and the carcass is reduced to bone, the Mariana Trench returns to its ancient crushing silence. The snailfish glides away, its body carrying a hidden burden, microscopic shards of a world it will never see. This is the ultimate paradox of the abyss. For millions of years, these creatures have mastered the most extreme physics on Earth, turning lethal pressure into a cradle for life. They have conquered the darkness, the cold, and the void. Yet they are defenseless against the chemical ghosts of human convenience. The natural law of the trench is absolute: you adapt or you vanish. Biology here has achieved the impossible, refining the very chemistry of cells to withstand 8 tons of weight. But how does a creature adapt to a predator that doesn't breathe, doesn't die, and never decomposes? The crushing kingdom remains the most resilient ecosystem on the planet, a testament to the sheer will of life to exist in the dark. But as the plastic remains buried in the silt, a permanent synthetic scar on the seafloor, it proves that no corner of our planet remains untouched. The abyss is not a separate world, it is a mirror. What we discard at the surface eventually finds its way to the heart of the earth, proving that in nature, there is no such thing as a way. The Mariana Trench has taught us that life will always find a way to survive the pressure of the ocean. The question is whether it can survive our impact. The kingdom remains silent and crushing, waiting for the next gift from above and the next cycle of a survival story that began long before us and will likely continue long after we are gone.